So, as you might know, the most well-known or the most well-established technology by Miltenyi Biotech is actually its magnetic activated cell separation system using the column-based platform, which is likely something you first got exposed to when you are trying to use our Miltenyi Biotech technology. And for most of you guys that has been never used the column-based technology, the first time trying that, you might have quite a few questions about how to do everything. Therefore, I think it's a good idea for me to make a 101 kind of instruction for anyone that is going to use our column-based cell separation system manually but never done that. So in this video, I'm going to do that, give you some tips or tricks about how to use it, and pretend that you have never done that before and want to learn everything. So let's start. So first thing first, you might have purchased a cell isolation kit or a microbeads from us, or you found that in your lab in the fridge and you are trying to use that for your cell separation. And therefore, this is typically you first get to access to when you are trying to do cell separation. And so you don't have anything, you don't really know how to do it, and you kind of have no idea. So I'm going to start from here and teach you how to do that. So the first thing that is very important actually is to take a look at the label over here. Every single kit box is going to have a label, and that label is going to give you some very critical information about the kit that you are having right now in your hands. The most important information, for example, would be the lot number as well as the expiration date number. That can easily tell you whether this kit is still in effect and whether you can still use it or it's been expired for a long time. So in which case, just simply discard that. All right. The next thing that is very important is that besides the name of the kit, the catalog number over here, a nine-digit catalog number that is starting with normally 130 for research product and then -3 number, -3 number. That is a very important information because that information can easily help you distinguish what is a product when you are trying to contact anyone from our company. And that can actually help you to easily search for your product information on our website to get more information or details about how to use this product. So let's just use this one as an example, all right? So this is a CD11B microbeads for human and mouse, and its catalog number is 130-049-601. So let me do that. And then once you enter that catalog number on our Miltenyi website, you will be able to easily find out this product. It directly actually introduces you into the product page. The most important thing you want to know from this product page is right over here. Unfortunately, it's not a very big button to click. Sometimes people actually don't know where it is, but it's actually always over here, locating right below the name of the kit. That is called a data sheet. Simply click that. It will transfer you to PDF file that is basically the protocol of how to use this isolation kit or how to use these microbeads for your cell separation. So once you have that, you basically have the manuscript, which is going to be your kind of Bible book that you can follow step by step to run through. And once you make sure that you exactly follow the protocol over here, you will be able to guarantee to have a very nice cell separation yield. All right. So here is a protocol. When you are running the experiment, I always recommend you to actually have a print out version that is going to be strongly helpful towards you to be able to follow the step by step on the protocol without making any mistake. So once you have the protocol, actually the most important thing you want to always check out on the manuscript is actually what kind of columns you would be able to use for this cell isolation. So that is exactly this section over here, which if you have the printed out version, not normally it's around the first page, around the second column at the bottom part. Sometimes it's on the second page as well. It really depends on the actual kit, but that depends. They will be always having this chat over here. So this chat is going to exactly tell you what kind of column you can be using for this cell separation, and what kind of column to use really depends on a few factors. The first thing is the purpose of this cell separation. For positive selection, which means you are interested in the positive target cell, all right? So the cell that has been attached to the antibody and the microbits, in that case, you can normally use an MS column, an LS column, sometimes XS, but that's relatively rare. So for those kind of column, you can use for positive selection, all right? In depletion, there is further a special column called a LD column, which later I will show you, basically have a little bit higher ion matrix to do a more efficient cell depletion. So if you are only interested in the negative portion and the positive portion will be discarded, you might also be able to use the LD columns as well. And to determine whether you are okay to use a column, a very important thing is basically to determine how much cell you have over here, all right? So typically speaking, when you are doing cell separation, there are two factors to consider about when you are determining the cell number. The first thing is actually the total amount of cell. So that is actually how many cells in total you have at the very beginning in your samples. Over here, you can see that for an MS column, the total amount of cells that it supports is 2 times 10 to the power of 8. That is 200 million amount of cells. While for LS column, that is maximally 2 times 10 to the power of 9. That is typically 2,000 million cells. So LS column, therefore, as you can see from the shape, will be bigger. It accepts a little bit more cells. But MS column will be decent if you don't have that much amount of cells to start with. Another very important factor here is the cell number for your target cell, the labeled cell. So the labeled cell, once again, is a positive portion, all right? So that is the cell that has been attached to the antibody, attached to the microbits. And when you add that to the column, it's going to be a cell that has been kind of suspended, locked inside the ion matrix of the column, later on ready for an elution or the flush out after you remove the column from the magnets. So that is your positive portion. And how much amount of a positive portion that you are going to estimate in your cell population will decide basically what kind of columns you will be able to use over here. So you can see over here that MS column, maximum number of total cells it accepts is actually 200 million cells, whereas the total amount of labeled, which is positive section, cell is actually 10 times 7. That is roughly 10 million amount of cells. Whereas for the LS column, the total maximum number of cells is 2,000 million, but a total amount of labeled cell it accepts is 1 times 10 to the power of 8. That is about 100 million cells. So when you are using this column in your cell sample, neither of the number can exceed the maximum. So for example, we are using a MS column over here, the total amount of cells you have cannot exceed 200 million, and the total amount of labeled cell you have could not exceed 10 million. And if either one of them is bigger than that number, you got to split the cell into 2 or even more amount to make sure every single column you have don't have either one of the numbers exceeding the maximum. So that is very important, because if you have too many labeled cells or you have too many total cells, there will be too many cells when you are running through the column separation. That will reduce your yield, and in worst case, that is going to cause clotting, which will significantly reduce your cell yield as well. So pay attention to that chart. Make sure the cell number you have is within the range. That is the first step to make sure you have a nice result from this. So once you decided the column, it's time for you to make sure that you actually have the magnetic separator that is right for the column. With that, let me bring the magnets over here. So with this MACS stands, we will be able to put on a few different kinds of magnetic separator for downstream applications. Nowadays, most of the magnetic separators Miltenyi offer is basically 4 types. You got MIDI, that is a single column version for LS column or LD column, and Mini, that is a single column that you have used for typically a MS column. And the quadro, which is normally used for up to 4 LS or LD column at the same time. This is a really big and huge one, and when you're buying this one, you typically are a lab that really likes our technology. So thank you very much. And last but not least, there's the octal, which is a 8-well parallel version of the MS column running separator that can support, as you can see over here, up to 8 MS column at the same time. And once again, if you're using this one, you probably like our technology a lot as well. So thanks again. But for today's purposes, I'm just going to use the medium and the mini because that can make our demo a little bit simpler. So putting column on the magnets is actually quite simple and straightforward. It's kind of automatic as well. Once you put that over here, the magnet is going to automatically kind of attract the column over here, and it's going to suck in directly. Only thing that you want to make sure is that the two supporting rack over here does not facing towards the inside of the magnetic, because that is going to block the fully attraction of the magnets and make the kind of column doesn't really fit in perfectly. All right, so that is very important, which is kind of common sense over here, but just make sure that. And once you make sure the supporting rack is facing outside, you can easily lock that in over here. Very stable, doesn't move at all. MS column is similar idea. The two supporting rack over here need to be facing outside, and once you have that, simply put the column onto the magnets over here and you are good to go. For both two types of single magnetic separator over here, up and down is fine over here. All right, so up and down over here, it still fit the magnetic column regardless, so you don't need to worry about that, to be honest. So once you have the column set up over here, one thing you will see from the protocol is actually it does have an option to recommend you to use something called a pre-separation filter. That is something look like this. The size of that sometimes is 30 micron, sometimes is 70 micron. The color of it is going to help you distinguish. The purple one we have is a 70 micron, and the yellowish kind of a filter is actually a 30 micron, depending on your protocol. Sometimes it requires you to use a 70, sometimes it requires you to use a 30, so use them accordingly. And when you have this protocol with the pre-separation filter, the way to put them on that is very simple. Simply lie down on top over here, MS column simply locking like that, and you will be able to have it. This kind of simply act as a strainer for you. So before you add in your cell solution into the column ready for the magnetic separation, the filter is going to be able to help you make sure the downstream flow is single cell solution only. It helps you to remove all the chunks to make sure that there's no clotting inside the column. So technically speaking, with a pre-separation filter, you are able to increase the input sample quality, and as a result, increase your sample yield downstream as well. However, as the protocol mentioned, this is not something essential, it is optional. So if your lab have a cost concern or simply prefer don't to have this plastic consumable stuff, that is fine. If you don't have that, simply make sure when you add in the cell solution, you add very gently along the edge, let it flow inside and avoiding any bubbles. So when you are having it added directly to here, make sure that your solution don't really have bubbles. And if unfortunately there are bubbles in your pipette tip, make sure don't add them to the column, because there isn't really that much cells in the bubbles, and those bubbles, when they get inside, is going to make there's a potential bubble clot inside the column, and that is going to reduce the cell yield you have after you rush through the column. So make sure you don't have the bubbles on it, and also make sure simply when you are adding the cell, you use a pipette tip to up and down resuspend them. Make sure they are very nice single cell solutions, because you don't really have a strainer-ish filters that is helping you to make sure that. So once you start adding the antibody with the microbeads into the cell according to the protocol over here, and start the incubation time, which typically is about 10 to 15 minutes, make sure to follow exactly the temperature condition that is suggested by the protocol over there. For live dat, for example, it's going to be in room temperature. However, if you are using some kind of microbeads or cell isolation kit, it might require you to do the storage or the incubation at 4 to 8 Celsius degree. And here is a very important thing. Putting the sample on ice is not 4 to 8 degree. Ice is actually making your sample stay at 0 degree, and therefore the temperature you have during the incubation is actually suboptimal. And as a result of that, that might potentially affect the antibodies bonding efficiency towards your target cell. So when you put that on ice, your yield simply might not be as great as you would expect it. And that could be a quite big issue. So don't put the sample on ice, put them in the fridge. And within that incubation time, you will be all good. So when you are waiting your cell during the incubation time, it is actually a good time for you to set up the column with some magnets, get sure everything is ready, and then start to prime it. Priming is actually adding the separation buffer into the column without the cell. And the whole purpose of that step is actually to wet the whole ion matrix structure within the column. So as a result of that, when you are adding your cell sample, the column matrix over here is kind of already in a wetting situation. And that is going to help you make sure the cells, they don't attach to the dry kind of matrix inside and it got stuck over there, and therefore potentially might have the clotting and reducing the sample yield. So priming is a very important step. And when you are do priming, nothing special, simply adding the sample into the column like that. In the real experiment, you might be using pipette gun and the tip, but I don't really have pipette in my home, so I'm just using the syringe. And the real cell solution is actually won't be this colorful. Today I use this one just for demo purposes, so you can see the color and the liquid a little bit more clear. But in your real sample, it might just be slightly brownish or almost like a colorless transparent. All right, so don't expect this color over here. This is actually the soil with water in my kitchen. I'm using that, so make sure you can really see after priming how it looks like. And once you see over here that after the priming step, the liquid actually start to dripping out, that is a procedure telling you that the whole column over here has been wetted. And as a result of that, your column is basically ready to go for downstream separation. And one thing over here, some of you might have a concern with is actually that after the priming, after the top liquid is fully gone, what is going to happen in the ion matrix. So you don't really have to worry about that. Right after all the solution has got primed, the solution within the ion matrix will kind of be acting like the liquid or the water in the soil. It will be sucked inside the matrix over here and hanging over there. So the whole matrix structure over here is going to be wet for a significant amount of time. So while you are doing this, after you priming it, if your incubation still got 5 minutes or even 10 minutes, it doesn't really matter. You will be fine for the column to be just hanging there for 10 minutes, 5 minutes, until you add the cell sample when they are ready. Don't do that overnight, because overnight is going to make the biomatrix exposed to the water too long, and as a result, it might causing rusty stuff, and that is not good for your cell yield. But like I mentioned, during incubation time, it's generally speaking a really good time for you to do the priming like this. So another very important thing to notice is that during the separation step, every time when you add some solution over there, starting from the priming step until the liquid is fully gone from the top, for the reservoir to be fully empty, don't add the second stage media. That including the priming step, that also including after you add the cell sample during the washing step, when you are adding more buffers in. Before you add the buffer, make sure all the solution here is fully gone over here for that. Otherwise, some remaining solution over here that still have the cell will be resuspended, and that is going to make them not get into the column or the matrix in time, and that will in the result potentially affect your yield as well. So make sure the liquid is fully gone before you add the next thing. As you can see over here, it's fully gone. So priming now is finished, and it's time for us to add the actual sample over here. And once again, simply add them in through the pre-separation filter and wait until it got finished. And when it's finished, generally speaking, you will be required to add a few times of the washing buffer to be able to wash through the column to make sure that you washed out all the negative cells. How much volume, how many times? Every single isolation protocol will be slightly different. So make sure you read the protocol carefully and make sure before you add the washing buffer, all the liquid once again over here need to be gone. So you shouldn't see any liquid in the reservoir. As you can see over here, it's gone. So it's time to add some washing buffer. It's the first time, and wait until it got finished. And now it's finished. It's time to add the second time of the washing buffer, and once again everything's the same. Add inside, wait until it got finished. Some protocol might require you to watch them 3 times or even 4 times just to follow the protocol. Today, I just want to show you a concept, so I don't really want to watch further. Simply after 2 wash, I would just say the separation is got finished and it's time to actually do the positive section. So the separation over here got finished and all the negative cell has been flow inside and collected at the bottom over here from either a collection tube or Falcon tube, totally up to you. And it's time for us to actually collect the positive section, which, as you might know, is right now hanging inside the ion matrix due to the magnets over here. And when you took it out the column, simply first took out the separator over here. But when you took it out the column, make sure it's taken out horizontally like that. Don't really take out them vertically straight up, because that is going to make the magnetic force kind of dragging down the whole column, and that might not be good for you when you are taking out the positive section over there. So once you took it out horizontally, apply them very gently to the collection sample over here, and then make sure that you have the punch over here ready for you on the finger over here. So that is going to help you make sure that you will be able to flush out the sample as soon as possible. And with everything ready, you now start to add the elution buffer and make sure that's a right amount of volume as recommended by the protocol over here. And once you add this inside the reservoir, I want you to make sure the plunge is applying on top and plunge them through as soon as possible without any delay. However, don't be nervous. Some of the researchers, once I heard it's going to be 0 delays, they become very nervous. They want to be really quick, and that actually makes them nervous. I've seen worst case where some of the solution got leaked out, or even the column actually dropped onto the floor, and that is not good. I don't want that. So make sure it's no delay, but don't really be panic. Once you add them, just simply apply the punch within 1 to 2 seconds. Only thing I want to make sure is that once you add the solution into the reservoir, don't wait for like 30 seconds, 40 seconds, wait until the solution are all gone. Add inside, punch them slow. Simply like that. Once you add everything inside, right after that, apply the punch and then push them through simply like that. And that is going to make sure all the positive section of the cell got pushed out to the bottom, and that is ready for collection. And the bottom part over there will be your positive cell population. So with that, this is basically finished. This is how the manual column-based cell separation using Miltenyi technology has been done. Over here, using either a MS, LS, or LDD column on either a MIDI or the mini. If you have the massive multi-column, bigger magnets, the same idea is applying. You are simply able to actually do multiple columns at the same time. So hope this is a really informative one-on-one kind of instruction, and that gives you a little bit ideas about how to run the column separation correctly. If you got any questions further about how to using this, or if you have suggestions about some other things that I haven't gone through for column-based cell separation, feel free to let me know either by email or leave in the comment below section, and I can further to see if I can put a new video to further introducing that. But thank you very much. Good luck with your cell separation. I think you will have a decent result. Have a nice day.